left off on combined like terms. Now we're going to isolate the variable.
Wait, we didn't do it. Oh, wait. We didn't, I don't think we finished. Really?
Yep, we combined them.
Okay.
Right, we combined the 3x and the 18x, negative 24 and positive 24. Okay, Liam, are you going to need a new seat?
No.
Okay. So we're going to flip our book up. And up at the top, remember we're going to write up at the top here, so put your hand up here at the top. That's where we're going to write. Rearrange the terms so that all variables are on the same side. So we talked about this a little bit before break. It's kind of like rearranging the furniture in your room. You don't really get rid of anything. You're just moving it to a different location, right? Maybe you don't want your bed by the window anymore. Maybe you don't want your desk in the corner anymore. You just move it. You're not throwing it out in the hallway. You're just moving it, okay? So we're going to rearrange things. And this is when you now use inverse operations because we cross the wall of equality. It's really exciting. Yep, this is C-R-O-S-S. Sorry. It's kind of hard to see with the glare and my writing. Okay, so now we're going to scoot down to the bottom part. We're going to write the equation where we left off. 21x plus 12 equals 4x minus 12.
When you draw the X, why do you have it like make it like the first time you draw it kind of?
So the real answer is I don't know. But what I want to believe is because maybe when I was learning this, that's what my teacher did, so I just mimicked it.
Well, why did your teacher do it?
I think it's so that it doesn't get confused with a multiplication symbol. Like the little curve makes it more of an X than a multiplication symbol. But I have no real answer for that. It's just something I do. But like when I'm writing, if I were to write something that had the letter X in it, it doesn't look like that. It's just with math.
That's weird.
I don't know. Brains are funny, right? Okay, so get out your red pencil. We're going to draw our wall of equality. We've got the left side and the right side again. Okay, so here's where you kind of get to choose your own adventure. It's like an adventure within an adventure. We need to we're going to isolate that variable, meaning the only term with a variable is going to be on a single side. Okay? So I can either subtract 4x from 21x, so minus 4x, or I can subtract 21x on both sides. personally like having negative values. So my preference would be to subtract 4x here and 4x here. So I end up with a positive 17x. This is where you and I might go separate ways when it comes time to solving these. As long as you get the right answer, again, I'm not particular on how you get there. The only drawback of subtracting 21 over here is now you have negative 17x and you have to think about your negative rules, which can get a little confusing. So if I can keep it positive, I'm going to. So I'm going to subtract this 4x using my inverse operations. Remember, we're balancing out the equation. So I have to, whatever I subtract over here, I have to subtract over here so it stays balanced. These are now gone. And I have 17x plus 12 equals negative 12. And just for good measure, let's make sure we all know that this is our wall of equality. That line right there is our wall of equality.
Why did you make them all capital except for the U?
Again, I don't know.
Well, I mean, the capital U is just the same as bigger. No, the lowercase has like the little thing at the bottom.
Yeah.
Oh, yeah, the Y is also not capital. And the I.
You guys are killing me. Okay. Are we all good with isolating the variable?
Yeah.
Rearranging the furniture? Okay, the next thing, the next tab is going to say two-stepper, step 1. Because now we are at a two-stepper status, which means we only have 2 steps until we get to the answer. Uh-huh. Every equation will get to this 2-step point. Every single one. If it doesn't start like this, it's going to get to this point. So let's go ahead and flip our page. We're going to write up at the top first. Use inverse operations. Add or subtract. So that's up at the top.
That's a star.
It is, yeah. Two steppers, step 1. Okay, so we're going to right where we left off again. So we have 17x plus 12 equals negative 12. I'm down on the bottom part again now. I'm going to draw my wall of equality.
Are we going to have problems like this on a test?
No. Well, I don't think so. You will have equations with fractions, but you would not have fractions on both sides. Okay?
And like how long would these normally take?
Not 2 days. Right? Because we wouldn't be writing the steps. You would just be using your book and going through the steps. You wouldn't have to write out the directions for each step. You wouldn't have to rewrite the problem every time. It would be one big thing. Well, I promise we're going to practice it a lot.
When do we have our next math test?
I don't know.
So not this week?
No. No. Probably not even next week. It depends. We have a lot of practicing to do. Okay, so the advice was use inverse operations, add or subtract. So remember, I'm still trying to get this variable term alone. So what am I going to do to this positive 12 so that this is now alone? I'm going to subtract, and if I subtract from this side, what do I have to do here?
Subtract.
Right. If I'm inverse operations, I have to balance it out. So subtract 12 from here. Subtract 12 from here. This is now gone because positive 12 minus 12 is 0. So I'm left with 17x equals negative 24.
That's weird. My whole problem is just that.
Right. Yep. Are we going to what? We are. So our next tab is going to be two-stepper, step 2.
Why did you write 2 at the beginning? It's like a word. And 2 at the one and 2 at the end.
Oh my gosh. Why is the sky blue? I don't know. Okay, so at the top here, for two-stepper step 2, we're going to use inverse operations. And this time we're going to multiply or divide. So if all I have left is the coefficient multiplied times the variable, I'm going to divide. If I have the coefficient divided by the variable, I'm going to multiply.
Is that an arrow or a star?
It's a star. Okay, Landon.
Cool fucking arrow.
No, that wasn't like an actual question.
It's a star. Here.
It looks like a star.
Here we go.
I think it looks like an
There you go. Is that better?
Yeah.
Okay.
Yeah.
No, that
Okay.
is fine.
So all we have left now is 17x equals negative 24. Whew. We have the left side and the right side that we're still trying to balance. Got our wall of equality. Parker, you okay? Yeah. All right, so Matthew, what am I going to do here? Because 17 is being multiplied by x. I'm going to divide both sides by 17. Those 17s are gone. I have my final answer of negative 24 over 17. And we're going to leave the answer as a simplified improper fraction. We're not going to get any funny business and make mixed numbers or decimals. We're just going to leave it like that. That is our answer.
What are we doing those 2 extra tabs?
I haven't told you yet. Isn't that so exciting? Now, if this was like negative 24 over 3, we can simplify that to a whole number, which your answer would then be negative 8. Negative 8.
8.
Right? Negative 24 over 3 would simplify to negative 8. But if you can't simplify it to a whole number, leave it alone. Don't touch it. Okay, tab number 9. Special situations.
Whoa. This just sounded like episodes in TV shows. Like there's like
I feel like there should be like a little, I should pause and be like, are you still watching? Like on Netflix, you know when they do that?
yeah.
It's kind of insulting because I'm always still watching.
I know, it's like,
Like, there's
have I
like-
really been watching for that long?
Like 7 hours, yep.
And there's like always that there's always at least like a 1-2-parter.
Yep.
to every show.
Uh-huh. TBC, to be continued, right?
Just have like names like special situations.
Okay. For this one, we're only going to write on the bottom part. We have 2 what-if situations. What if
Can we name it anything?
It's called special situations. For number 9, special situations.
What if?
And this is the what if edition.
Wait, what if? Or do we write?
We're not writing anything on the top. We're just staying all on the bottom section here. What if my answer looks like this? So what if you do all the work and you end up with something that has this, or something that's just like two numbers that clearly don't equal each other? Because that can happen. Sometimes you're going to put a lot of effort in, and you're going to get down to the bottom, and you're going to be like, oh, you've got to be kidding me. Because this answer is actually no solution, meaning that nothing will work for the value of x.
What was the point of doing it?
I mean, that's why I said at the end, you'll be like, you've got to be kidding me, right? Because 3 times a number is never going to equal 7 times that same number, right?
I thought you were gonna pull out some like magic trick to magically turn it into.
Nope, it's not going to work. And just like -6 will never equal 2. Okay, so your answer would be no solution.
It could though.
The opposite of that So what if I end up in the left side is identical to the right? So the opposite of no solution would be
You did it.
the answer can be any value. That means that x doesn't just have one value. X can be anything. And that has a special name too mathematically. Infinite solutions. So maybe you're working your way through and you get to the step and you're like, wait a minute, the left and right are identical. 5 times 3 plus 4 will equal 5 times 3 plus 4. 5 times -7 plus 4 will equal 5 times -7 plus 4, right? Any value will work. Any value will keep that balance. Number 10 is called inequalities. We're not going to do anything for that today. So next to number 10, write inequalities, and we'll fill that in when we get to inequalities. Because that's its own special other situation.
This isn't gonna take 2 days. It's gonna take 3 days.
Yeah.
Almost. Okay, so what I need to do right now is hole punch your flip book. So you're going to bring it back to me, first row only. I will hole punch it for you. Because I don't trust